Hello students, welcome to another exciting lesson of physics with Bhardwaj Gurukul. Today we are diving into one of the most important and interesting chapters, laws of motion from class 9th ICSE. By the end of this video, you'll not only understand Newton's three laws but also how they apply to everyday life. You will be able to solve numerical and avoid common mistakes. Let's get started. Law of motion. In this video, you will learn the Newton's first, second, and third law, inertia, force, and action-reaction pairs, derivation of equations of motion, real-life applications, and numericals and concepts. Here's an interesting question for you. Why do we move forward when a bus suddenly stops? Or why does a rocket shoot upward? These everyday experiences are beautifully explained by Newton's laws of motion, which we will explore today in depth. Let's begin. Law of motion. Newton's first law of motion, the law of inertia. An object continues to be in the states of rest or of uniform motion in a straight line unless acted upon by an external or unbalanced force. Example, book resting on a table until pushed, a ball rolling and stopping due to friction are some common examples of Newton's first law of motion. This means that objects don't change their state by themselves. It's only when an unbalanced force is applied that the object accelerates, slows down, or changes direction. Real life examples, a bus suddenly stops and you move forward due to inertia of motion. When a bus suddenly stops, your lower part, which is in contact with the bus, stops, but the upper part of the body still tries to be in motion. That is the main reason why you tend to move forward when a bus suddenly stops. The key term in inertia, the tendency of a body to resist change in its states of motion. One more definition of inertia can be adding the word property in front of the definition of Newton's first law of motion. Newton's first law of motion is also called the law of inertia. Keyword is inertia, that is the natural tendency of objects to resist any change in motion or any change in the acceleration. Examples are a book stays on a table unless pushed. When a moving vehicle stops suddenly, the passengers lurch forward due to inertia of motion. Types of inertia, there are different types of inertia. First is the inertia of rest, the second is the inertia of motion, and third is the inertia of direction. Example, dust particle fall when a mat is shaken. When a mat is shaken, the mat is in motion but the dust particle tend to be in the state of rest. That is the main reason why dust particle fall down. Inertia of motion, example, the body moves forward in a stopping car. Again, when a car stops, the lower part of your body, which is in contact with the car, stops, but the upper part of your body tries to be in the state of motion, and that is the main reason why you tend to fall forward when a car suddenly stops. Inertia of direction, example, sparks fly tangentially from a rotating wheel. When a wheel is rotating at a high speed, you may notice sparks coming out of it in the direction of the wheel rotating. Coming to the Newton's second law, the Newton's second law gives us the mathematical definition of force. It states that the rate of change of momentum of an object is directly proportional to the applied force and occurs in the direction of force. Example is pushing a light box versus a heavy box. More mass needs more force. If you push a light box and again you push a heavy box, you will notice that you will need to apply more force to push the heavy box. Here we have a formula for the Newton's second law. F is equal to ma, where F stands for force, m stands for mass, and a stands for acceleration. The SI unit of force is Newton, mass is kg, and acceleration is meter per second square. Example, if you push two trolleys, one empty and one full, the empty one moves faster. Why? Because with the same force, lighter mass is equal to greater acceleration. Again, you need more force to push a body of more mass. Coming on to the Newton's third law of motion, action and reaction. The Newton's third law states that for every action there is an equal and opposite reaction. This law explains how motion happens. Example is a rocket launching, a swimmer pushing water backwards, gun recoil. When a swimmer pushes the water backward in a reaction, the swimmer moves forward. The force always act in pairs but on different bodies, and both forces are equal in magnitude but opposite in direction. Real life example are a swimmer pushes water backward, the water pushes them forward. The main reason why the swimmers push water backward is to move forward in the water. Second point, when a bird flaps its wings downwards, it pushes it upwards. When a bird flaps its wings downwards, the air pressure also pushes it upwards. The bullet is fired and the gun recoils. When a bullet is fired, the gun is also pushed behind because of the force applied by the air. The rocket propulsion, gas pushed down, rocket moves up. When a rocket is propulsed into the air, the gas pushes it down, and as a result, the rocket moves upward in the air. Equations on motion. Let's connect equations, laws to three important equations that help us to solve numerical problems. First law, V is equal to U plus AT. Second law, S is equal to UT plus 1 by 2 AT square. V square is equal to U plus 2AS, where U is equal to initial velocity, V is equal to final velocity, and A is equal to acceleration. T is equal to time and D is equal to displacement. These equations assume constant acceleration. Visual object thrown upward and downward motion plotted. Now let's move on to some numericals which are important for the chapter law of motion. A car accelerates from rest to 20 meters per second in 5 seconds. Find the acceleration and the distance traveled. Given U is equal to 0, V is equal to 20 meters per second, time is equal to 5 seconds. The initial velocity is given 0, the final velocity is given 20 meters per second, and we have the formula A is equal to V minus U divided by T, which is equal to 20 minus 0 divided by 5, and we get the answer 4 meters per second square. This is the acceleration, which is 4 meters per second square, and we have to also find the distance. So the formula for distance is S is equal to UT plus 1.5 AT square. Then we'll put the values and the final answer is 50 meters. Therefore, we get the answer acceleration is 4 meters per second square and distance is 50 meters. Second question, a car of mass 1000 kilo accelerates from 20 meters per second to 30 meters per second in 5 seconds. Find acceleration and force applied. Here we have the initial velocity 20 meters per second, final velocity 30 meters per second, and time is 5 seconds. Then we have the formula for acceleration V minus U divided by time, which we have 2 meters per second square. And then formula for force applied is equal to F is equal to ma, and we'll put the values to get the answer. 2000 Newton of force was applied to accelerate the car from 20 meters per second to 30 meters per second. Newton's second law, F is equal to ma. Now, a box of mass 10 kilo is pushed with a force of 50 Newton. What is the acceleration produced in the box? So, given mass is given 10 kilo and force is given 50 Newtons. Using Newton's second law, we can derive that A is equal to F divided by m. And then we'll put the values and then we'll get the answer 5 meters per second square, which is the acceleration. Now Newton's first law, which is based on the inertia concept, a ball is lying at the rest on the floor. It remains at rest until a force of 5 Newton is applied. What does this prove? Now this question is a type of theory question in which we are asked to prove the Newton's first law. Then you can just write the statement of the Newton's first law, which is an object at rest stays at rest unless acted upon by an external force. It demonstrates inertia of rest. The question is an example of inertia of rest that we have studied in the previous minutes. Now we have got the Newton's third law, action and reaction. Question: a gun of mass 2 kg fires a bullet of mass 0.05 kg with the velocity of 400 meters per second. What is the recoil velocity of the gun? By conservation of momentum based on Newton's third law. Initial momentum is equal to final momentum, which is equal to 0 is equal to mass of bullet multiplied by the velocity added by mass of gun multiplied by the recoil velocity. Then we have to put the values and then we'll get the answer 10 meters per second in the opposite direction. As we studied, when a bullet is fired, then the gun will react in the opposite direction of the bullet fired. Next question: a body of mass 5 kg initially at rest is subjected to a force that produces an acceleration of 2 meters per second square. Find the distance traveled by the body in 4 seconds. So here we're given the mass 5 kg, acceleration is 2 meters per second square and initial velocity is 0. Time is given 4 seconds. So then we will put the formula h is equal to ut plus 1 by 2 at square. By putting the values here, we'll get the answer 16 meters and the distance traveled by the body of mass 5 kg is 16 meters. Here are the real life applications of Newton's law. Where do we see Newton's law? Everywhere. First law, inertia. Seat belts prevent you from moving forward during sudden braking. As you've studied that when a car suddenly stops, you tend to fall forward because of the lower part which is in contact with the car stops suddenly, but the upper part of your body tries to be in motion, and that is the main reason why you tend to fall forward. Now the second law is given here: kicking a football versus a basketball, more mass is equal to more force needed. When you kick a football and then you kick a basketball, you will notice that there is some lightness in the basketball than the football, because the football is obviously heavier than a basketball. Third law, which is based on the action is equal to reaction. Jet engines, walking, jumping, even birds flying and walking are the examples. Now as you studied, as you throw a ball on the wall, the ball comes back to you. The action you did throwing the ball on the wall and the reaction you get, the ball comes back. This is the third law of Newton acting in the everyday life. Now quick tips for success in this chapter is: Newton's laws are not just theory. They describe our world. Mastering them makes you understand how everything moves. Keep practicing those formulas and solving questions. See Newton's law as not as theory. Do not learn Newton's laws as theory because they are very practical in our daily life. If you will try to find them in our daily life and relate them with the daily life, you will be easily remembering those laws and keep remembering those formulas, revising those formulas and solving questions for your practice, and then you can achieve the success in this chapter, laws of motion. Now here's the last thing. Thanks for watching this video. Do not forget to like, share and subscribe to Bhardwaj Gurukul for more awesome physics content. This is Bhardwaj Gurukul, making physics fun and easy. See you in the next video. Bye bye.